Thank you, Roger, for taking the time to speak to us tonight. We are interested to see your advanced VPC networking. You can take it away from here.
Okay. Good evening, everyone. My name is Roger D'Souza. I'm the practice manager for enterprise security and automation at CA Southern Africa. It's based in Johannesburg. The topic for today, for those who have joined this for the first time, is this is a continuation of the AWS VPC Fundamentals webinar that we had conducted a couple of months ago. So this basically, this webinar will just basically cover the concepts, a refresher of the concepts, and then go into some of the topics like VPC Flow Log, Direct Connect, VPC Peering Connections, transit gateway architectures, and so on. And then I've set up an environment so that we can actually walk through some of the demos step by step, so that people who are not quite familiar with the VPC can actually see and learn hopefully learn something new from this webinar. So, so the first part is the VPC refresher. I just wanted to refresh the VPC concepts before I proceed further with the demo. So, can you guys hear me?
Yes, we can.
Okay, great. So essentially, a VPC is like a virtual private cloud. It is like a container on the AWS cloud in a multi-tenant setting. So essentially, you create your own VPC cloud, or other organizations create their own VPC cloud, and then these clouds act as containers for all the AWS resources that you create within the cloud. So essentially, you have the AWS cloud, and then within that you have several regions. Regions are geographically located regions, so such as US East 1, US West 1, so on and so forth, AF South Africa, South 1, and so on. And then within these regions, you have multiple availability zones, which are basically data centers. You can imagine, say, for example, in Belleville, in Cape Town, in the Western Cape, you would have 3 availability zones. So Cape Town would be a region, and then within Cape Town, you would have 3 availability zones. And then at each of those 3 locations, say, for example, in Belleville, there would be 1 or more data centers, and those data centers form a part of a single availability zone. And one availability zone can potentially host thousands of servers to the tune of about 300,000 servers. So what are the components of a VPC? You have a VPC is like a regional construct. It basically spans an entire region. So basically, if you have 3 locations in Cape Town, you would have 1 VPC that would span those 3 locations as part of the that Cape Town region. And then within the VPC, you would have availability zones, and then within those availability zones, you would have subnets. Subnets are basically almost like subnetworks on a traditional network. And then within these subnets, you would have Ec2 instances running, or any other AWS resources that you provision and that runs within this. So here is another example. So you have 2 regions here on this slide. You have Northern Virginia region and the Cape Town region. So the Northern Virginia region has the prefix US-East 1, and the Cape Town one has AF South 1. And then within that, you have 1 or more availability zones. For example, the Northern Virginia region has about 6 availability zones, and the Cape Town region has about 3. So here on this slide, you can only see 1 availability zone, but you can have 1 or more availability zones. So those availability zones would basically house the data centers. And then within those data centers, you would have your AWS resources like hardware servers and compute resources. So on this slide, what you're seeing is, I will walk through this slide when I do the demo. I just wanted to introduce this concept. So what you're seeing here is, if you look the outermost container is the AWS cloud, and then within that you have this is for a specific region, and then within the region you and then within the region you would have two availability zones, so one in Belleville, for example, and one at some other location. And then within those availability zones, you would have subnets. And when you create a VPC, it comes with a default route table that's called the main route table. And you can create more route tables and associate subnets with those route tables. We will go through that very quickly when we do the demos. So here you can see, again, in the Cape Town region, for example, you have two availability zones, AF South 1 and AF South 1B. So 1A indicates one availability zone and B indicates the second availability zone. And then you have two subnets. Usually there is a convention that AWS follows when they're sharing their icons and these drawing resources. You have these green colored subnets which indicate public subnets and the blue colored ones that indicate private subnets. So private subnets cannot be accessible from the internet. So what you're seeing here essentially is you have a VPC, and to that VPC you have an internet gateway connected. The internet gateway allows resources outside the VPC to connect to resources within the VPC and vice versa. Now, when you create a VPC, you get a default route table, and that route table has one single entry, like so. It has 10.1.0.0/16. Now, what happens then is you attach an internet gateway to that VPC. By attaching an internet gateway, now you have allowed the VPC to connect to the internet. However, these subnets or the resources within these subnets still cannot connect to the internet until you add a route entry in the route table. And the route entry would be, for example, like this: 0.0.0/0, and then to go anywhere you use the internet gateway as a destination. So that would imply that a public subnet EC2 resource would reference this route table, see that it needs to go to an IP address that is not local, and then go through the internet gateway appliance, and then outside to the internet. One of the things that trips people off is that these EC2 instances that are inside the subnet, they don't actually have, they are not actually aware of the public IPs. It is the internet gateway that maintains a mapping between the private IP and the public IP when it sends traffic out or receives traffic in. So that's the role of the internet gateway. Then what you can do is, for example, if you have some secure resources that shouldn't be accessed from the internet, then what you normally do is you put them in private subnets here, like they are marked in blue, and then these resources cannot be accessed from the internet. But in some cases, you want to, for example, update the operating system using some external internet-based repository server, for example. So in that case, you still want to access the internet using NATing, but you don't want external resources that are on the internet to access that EC2 instance. So for that, what you do is you create a NAT gateway and you create a separate routing table, and the NAT gateway needs to be in the public subnet so that the NAT gateway can access the internet, and then your private subnet will access the NAT gateway, and then through the NAT gateway it will go to the internet. But any external services will not be able to reach this private subnet. That's what the NAT gateway ensures. When you create a subnet, for every subnet, there will be a set of reserved addresses. And this is the list of reserved addresses. You have the network address, which is the subnet address in a /24 network. Then the network +1 address, which is the address at which the router listens, the network plus 2 address at which route 53 DNS services are available, .3 address which is reserved for future use, and the broadcast address. You cannot do broadcasting in a VPC. Then the next concept we'll cover is VPC Gateway Endpoints. There are two types of gateway endpoints. Gateway endpoints are for DynamoDB and for S3. S3, for example, is a global service. It's a public service. It is accessible from the internet. But sometimes you have like a private subnet and you don't want that private subnet to have access to a public service over the internet. So what you do is, in order to avoid going through the internet, you actually create a gateway endpoint. Gateway endpoints are available for S3 and DynamoDB. So through the gateway, by creating a gateway endpoint and associating it with a specific route table for the subnet, what the gateway endpoint does is it creates something called a prefix list, and that enables communication between the subnets and the S3 bucket without having internet access. So what we will do during the demo is we will create a VPC, or actually have created a VPC without attaching an internet gateway. So essentially it has no access to the internet. So an EC2 instance on the private subnet still needs to access some S3 bucket. So in order to do that, we will create a VPC gateway endpoint, and then we'll associate that endpoint with the subnet, and then enable access from the disk without having the EC2 instances have access to the internet. Then we will cover VPC Flow Logs. What are Flow Logs is basically they're used for troubleshooting. So essentially they capture packet metadata. They do not capture the contents of the packet. So they are different from intrusion detection systems. For example, the intrusion detection systems will actually inspect the payload of the message as well. VPC Flow Logs, on the other hand, only inspect the metadata, the IP address, the source, destination, protocol, and so on, the account information, and so on. So we will just walk through how the VPC Flow Logs are configured. And then VPC Flow Logs can be configured to send the data that they collect at aggregation intervals to S3 and CloudWatch logs. CloudWatch is a monitoring solution, and S3 is S3 buckets. So one must remember that VPC Flow Logs is not real time. So basically, if you're expecting real time triage of issues, then you cannot use VPC Flow Logs, because it will wait for that aggregation interval before it actually writes to that destination, whether it's S3 or CloudWatch logs. And the Flow Logs can monitor at three levels. It can monitor at the VPC level, where it monitors all the interfaces at the VPC. It can monitor at the subnet level, so it monitors all the interfaces within a specific subnet. Or it can monitor at a specific EC2 instances interface itself. So the granularity, you can do it at 3 levels. And during the demo, we will do it for the interface level. Then what the other concept is a VPC peering connection. So remember I said a VPC is like your own virtual cloud on AWS shared infrastructure. Now, but one of the things you want to do is say there are two organizations and they want to share information between themselves. So what you can do is you can create a VPC peering connection between your VPC cloud and the other VPC cloud, and this peering connection can basically allow traffic to flow between the two VPCs. The way it works is, just look at this example. So you have VPC A and VPC B, and for each VPC you assign a CIDR block, which is basically a block of IP addresses. The /16 indicates that there are 2 octets that are occupied for network and the remaining are host address. So you get 65,000 plus IP addresses. Okay, so for VPC A, what this routing table is saying is, for VPC A, if you want to go to this CIDR block, then all your traffic is within the VPC. So all your traffic is within this VPC. Similarly, for VPC B, if you want to go to this CIDR block, all the traffic is within the VPC. But if you want to go to the other VPC, then you should use the peering connection. So that PCX is the peering connection. Okay, so here is another example with one VPC paired with two VPCs. So essentially you have VPC 10.0.0.0/16 and 192.168.0.0/16. Both of them are paired with VPC A. VPC peering is not transitive. What it means is just because you paired VPC B with VPC A and VPC C with VPC A doesn't mean now you can access VPC C resources without having a peering connection between these two VPCs. So it cannot flow through this VPC A and go over to VPC C directly. So VPC peering is not transitive. So that implies that if you have thousands of VPCs, you're going to have, in order to do a full mesh connection, you will have multiple peering connections. And that can result in a huge admin overhead. Imagine if you have 3 VPCs, you will have potentially 6 peering connections. So if you have, I don't know, hundreds of VPCs, you will have thousands of peering connections. Every route table has a limit on the number of entries that you can have within that route table. The limit is about 1,000 routes. So which means that if you have a very complex network, you cannot do a full mesh, because you will run out of route entries that you can add to a route table. So in order to address this complexity, we came up with transit gateways. So let's just now move back to the screen and let me show you what I have set up for this demo. Now, I wanted to demonstrate some of the more interesting features as well. So what I did is I created multiple accounts. Let me walk you through these accounts so that it gives you an idea of how this demos will be set up. So the first thing is, like I said, look at this outer box. This is the AWS cloud. And then within the clouds, you have several geographical regions. So in this example, you have actually 3 regions. You have North Virginia, that is in 2 regions, and then you have Ohio. Sorry about that. Ohio. Okay, and the convention, like I mentioned, a region has a prefix. So US-East 1 is North Virginia, and US-East 2 is Ohio. And then within those regions, I've created VPCs. So the question some of you might be thinking of is, why did you actually create 2 boxes for regions for US East 1? So for example, why is there a box here and a box here? The reason I did that is I wanted to also demonstrate another feature, that is multi-account VPC peering. So basically, you are peering your account, your AWS cloud, with your partner's account. So that's why I created multiple accounts. Here we have Apps for Life Shared, which is a shared services account. Then we have Apps for Life AWS Pretoria account, which is the account that I will be doing most of the demo in. And within, so this Pretoria account is part of 2 regions. So basically you have US East 1 North Virginia region and US East 2 Ohio region. Okay. Now, one of the challenges with setting up so many accounts is, once you log into Chrome and onto the console, then you can, when you launch another tab, it will, because of the cookies that are already stored for that login session, it will open it will keep opening the same account again and again. So you have to log in and log out all the time. So in order to overcome this, I've used a Chrome feature called multi-containers, multi-account containers. So this is a Chrome plugin. It has nothing to do with AWS or with these accounts. And then I created three containers. And then within those containers are acting like, Firefox containers are acting like cookie and session boundaries. So by virtue of doing this, I can actually open 3 accounts simultaneously and navigate between the accounts and demonstrate all the features such as VPC peering between the accounts. Before I continue with the demo, is there any questions? Do you have any doubts so far? Okay, great. So let's just this. So the way you identify which account I'm currently using is just to give everyone an indicator. You look at the top in the address bar over here, and you should see the account that is currently being used. So like I mentioned, I have apps for live shared, and I've also used different color codes. So if I click at AWS Pretoria, it's this reddish color, and then I've also created another advanced demo container which has the 3rd account which is logged into, and that's apps for live advanced. So just to demonstrate that I'm using different accounts, you can see the account IDs are different. See, it's 8.4, and if I go to another, let me just close the tabs that are not here. Apologies for that. Okay, so now to open a multi-container account, what I do is I click on this link, and suppose if I want to go to the AWS Pretoria container, so I just click on that first. So I am now in the AWS Pretoria container. I have bookmarked some links for every management console. So I'm clicking on the AWS Pretoria management console now. So that basically opens the AWS login information for Pretoria, and that's the sign-in link for that. And then I've saved a number of passwords. Another cool feature of Google, if you guys are not aware, is this feature where you can, if you have one email address, you don't have to create multiple email addresses for each account that you create on AWS. What I've done here is I'm using one email address, and then I just put plus and something like a keyword. For example, I put advanced networking edit ADV-NET. So essentially what Google does then is when it gets an email for this specific email address plus ADV-NET, and this is a Google Gmail feature, right? So you won't get it with every email address. Then essentially it will route the email to roger.cert@gmail.com. So you can create multiple AWS accounts without having to create multiple Google accounts for your root user account. Hopefully that gave you an idea of something a cool feature that you can use. Okay, so now I'm logging into, I've created admins for each one of these accounts. So I'm logging into the Apps for Life Pretoria account, right? So now once I log into the account, you select the region. Remember, the region is the geographical region, and you can see the prefix here. After logging into the region, if I want to navigate to the VPC, I click on VPC and I can click on navigate. I have gone through this demo before, but I'm going to quickly create a new VPC just for people who didn't attend the demo. It will take me a minute. So essentially in every region, you will have one default VPC. Remember, the VPC is a regional construct. It is not a construct that is confined to a availability zone. It is a region-wide. So in Cape Town, for example, you have 3 availability zones, but you would still have one VPC that would span all 3 availability zones, which are geographically distributed. Okay. So now for this demo, let me just quickly create a VPC. So I'll say my test VPC. Now I'm creating a cloud. I can just say 10 10, for example, CIDR block /16. So the /16 indicates that these two IP addresses are part of the network, and this is my host address space, which gives me 65,000 plus IP addresses. If I were to use /24, then it would give me, so this is my network address space, and only 24 8 bits are my host address, which will give me 256 IP addresses. But remember, out of those 256, there are a couple that are reserved by AWS in every network. So it will give me 251 IP addresses. What I'm going to do now is I'm going to create a /16 CIDR network. I'm going to choose IPv6 address. AWS allocates from its block of IP addresses a /56 range that to your VPC. You can only allocate one IPv6 CIDR block per VPC. You can allocate up to 4 IPv4 CIDR blocks per VPC. So I'm going to create a VPC. Now, as soon as I create this VPC, in order to make the demo easier, the last time we had trouble trying to locate the routing table. So what I did is I've also tagged all of the VPC that I've created. So as soon as you create a VPC, it creates a routing table as well. And the routing table, let's look at what the address routes are in the table. Currently, I allocated a 10.10.0.016 CIDR blocks. So there are 65,000 IPv6 addresses, and there are millions of IPv6 CIDR addresses. Okay, millions or billions of CIDR addresses. I don't even know how many. Now, when you look at subnets, there are no subnets because I haven't created a subnet within a VPC. Let me just go and create one subnet to demonstrate this concept. So before I do that, let me just tag my VPC so it's easier for me to read. Okay, so my VPC is called my test VPC. I'm going to create a subnet quickly. Create subnet. So you can see my test VPC. I've chosen that, and as soon as I do that, I can sub-network or break down this network into chunks and allocate it. So I'm going to, for ease of, you can break it into chunks of different types. So you can do 0.0/17, for instance, /18, 19, 20. For being easy to use, I'm going to use /24. It's just easier for me to break down the address. Okay, so that means that these three now became the network block, and these bits are for the sub-network address. Okay, so I'm going to create 2 networks just for demo purposes. Okay, so that portion needs to come here, and you can name your VPC. So I'm just going to follow some convention, my VPC, and I'm going to just make it a public VPC, and I'm going to say in availability zone A1. Okay, so I'm going to select A1, and remember the subnet is locked into the availability zone. It does not span the whole VPC. It is locked into a specific availability. Okay, I'm not going to assign this, and if I want, I can create another subnet. So I'm going to do that quickly. So I'm going to say 10.10. And instead of trying to start at this, I just followed some convention for other VPCs so that it resonates with everyone. I'm going to just do this 10. So the second VPC I'm going to create is a private VPC. And I'm going to put it in availability zone 2. I could put the same in availability zone 1, but I'm just going to go ahead and put it in availability zone 2. Right? And then again, I'm going to address another, add another CIDR block, and this time I'm just going to call it 20. So I'm just going to leave gaps of 10 in each availability zone. And I could have started at 0. For instance, I could have said 10.0.0/24, or I could have started at 1. But just to make it easier to allocate intermediate blocks, I've just followed that. Okay. Now, in this case, I don't want to assign an IPv6 address. Say, for example, in this case, I want to assign one. So I can choose custom IPv6 address and put slash. Now notice this, the subnet mask is /64 and not /56. So it is subnetworking that 56 bit network address into subblocks. So it's using another 56. So it's 8 bits to break down the network. Okay. So I create another subnet. Now, by virtue of creating this subnet, I still cannot, if I created an EC2 instance, if I created a VM within that subnet, I still cannot connect to the internet. In order to connect to the internet, I need to click on create internet gateway. You need not connect to the internet. Suppose if you want to keep your VPC isolated, for example, you're running a VPC and you're just running some computational jobs, and then that VPC is maybe writing to a S3 bucket, which can be accessed over a VPC gateway endpoint, then you don't need access to the internet. Okay, but for my demo purposes, I'm going to do that VPC and then internet gateway, IGW. Okay. Now, after I create an internet gateway, this gateway attachment is highly available by across the region, the whole region. So you don't need to manage, the availability of this gateway endpoint. AWS uses hyperplane under the hood to basically facilitate and uses some advanced shuffling algorithm. It's called shuffle sharding that basically allows multi-tenant usage of the network bandwidth under the hood, right? But now this gateway endpoint is created, internet gateway endpoint is created, but it's not attached to a VPC. So I can choose a VPC. You can only attach one gateway endpoint per VPC. So now this is great. Now I've created a VPC, I created 2 subnets, I created a gateway endpoint. But that doesn't mean I can still access the internet. In order to access the internet, I need to go to the route table of the gate of my VPC. Let me just tag this VPC as my VPC RTB route table. And then what I'm going to do is I just want one of the subnets to have access to the internet and the other one to not have access. So I'm going to edit the subnet associations and just add one of the subnets. And the one I know is because the public one I had added a IPv6 address, so I'm going to choose that one. Okay. So I added one subnet to the route table. And if I look at the routes, you can see that by default it adds 2 routes. One for IPv4 and the other for IPv6. But now to access the internet, you need to add another route. And the route is 0.0. So if I want to go to to the internet, then I must use some sort of interface, and that interface is the internet gateway. Okay, and then click save. So that essentially created the internet gateway. And now if I were to create a EC2 instance and create an EC2 instance in a subnet that is currently attached to the internet gateway, it will route the traffic. But what I can also do is I can create another route table. So let me just call this my VPC main, just so that it's the main route table. You can see that it is the main route table for this VPC, my test VPC, right? So I'm going to create another one, and I'm going to call it my VPC and private. And again, I'm going to choose the my VPC. And I'm going to, it's already added, so the name tag is already added. And then what I'm going to do is, I'm going to add the other subnet to the private VPC, my VPC private. I'm going to add I'm going to associate the other subnet with it. Now by associating this other subnet, which does not have the IPv4 CIDR, basically this subnet will refer to all the routing rules. This subnet will refer to all the routing rules defined here. And as you can see, these routing rules don't have access to the internet. So by virtue of adding any EC2 instance to this subnet, I will not be able to access the internet still. If I were to, on the other hand, add a EC2 instance to the main VPC routing rule, main VPC routing table, added to this subnet. If I were to add an EC2 instance into this subnet, I will be able to access the internet. But remember when I said I might want EC2 instances to not be reachable from the subnet, but maybe to access internet-based services. So for example, if I want to update my Linux instance by patches which are available from Red Hat, and this Red Hat repository server is on the internet. So in that case, I need to access the internet, but I shouldn't be able to access from the internet, be able to access this server. So one way to do that is to go to the private VPC and add another routing rule, but use a different appliance. So currently, if I were to add a internet gateway appliance, then it would have access to the internet. Then it would no longer be a private subnet, it would be a public subnet. So to prevent doing that, I create another VPC resource called a NAT gateway. NAT gateways are created in a specific availability zone. They are not highly available across availability zones, unlike an internet gateway. An internet gateway is a regional construct. A NAT gateway needs to be added to specific availability zones into specific subnets, public subnets of those availability zones. So if you have two availability zones with public subnets and private subnets, and if you were to only add NAT gateway in one of the public subnets, if that whole region went down, you will not have access to the internet from the other availabilities. So because we created only one subnet, we are going to only create one NAT gateway. So I'm going to my VPC NAT gateway and then choose the private subnet. So choose the private subnet, and the NAT gateway also needs a public IP. So I will allocate an EIP and create the NAT gateway. So by virtue of doing this, now I created I made a mistake. The NAT gateway must be created in a public subnet. Why? Because the NAT gateway still needs access to the internet, but must be accessed from the private subnet. So let me just create another NAT gateway. So my VPC NAT gateway, and I must create the NAT gateway in a public subnet. But now when I go to the route tables, I go to the private subnets, the other route table that does not have the public this, and add a route now, and then choose the NAT gateway. Okay, I'm not sure which one. So now by creating EC2 instances in this subnet, I'm allowing this EC2 instance to download patches, packages, and so on from the internet. But if someone from the internet needs to access an EC2 instance within this subnet, within this associated subnet, then they will not be able to access any of the services. Okay, so that's the concept. So for people who joined recently, I just covered the basics quickly. Now let me just go to peering connections, because that's the rest of the demo. So essentially now what we did is, let's just go back to the diagram. We created a VPC very similar. We created a VPC, say for example, very similar to this within the Northern Virginia region. We created an additional route table. We associated an internet gateway with that route table. We created another route table for private access. We associated a NAT gateway as the exit point for that route table. We created a NAT gateway in the public subnets. Remember, the NAT gateway is created in a public subnet, but is accessible from the private subnet. So basically, if you want to access the internet, EC2 instance over here. So for example, if this EC2 instance over here, needs to access the internet, what it will do is it will look at its own route table, and in the route table there will be an entry that says 0.0.0.0 go to the NAT gateway. So it will go from here to the NAT gateway, which is in the public subnet. And this NAT gateway has access to the internet because there is a route table associated with this NAT gateway. And that route table has an internet gateway as an endpoint for the internet. So it will go from here into here and then out of here. Does that make sense? Do you guys have any questions so far before I move on to VPC peering?
Nope.
Okay, great. So hopefully everyone is following. If you're not following, I have no problem explaining things again. Okay. Now what we're going to do is we're going to create a peering connection. Okay. So what we will do is okay. I don't know what happened there. Okay. Create peering connection. Suppose if you want to link my VPC, let's just follow some convention, my VPC, and I want to link it to the HR network. So if I go back to my diagram, there is a VPC called HR and there is a VPC called my VPC. Sorry. Okay. Now the peering connection can be between regions, between accounts as well. Now let me show you all those permutations. I can create the peering connection from both sides of this. So one party becomes the requester of the peering connection and the other party becomes the acceptor of the peering connection. You can create peering connections between two VPCs in your own account, between VPCs across accounts, between VPCs across regions. That is called cross-region VPC peering. So basically, if you were to create one VPC in Cape Town, for instance, and the other in Northern Virginia, and now you want to communicate between these VPCs, so they are in different regions. So I have a VPC in Northern Virginia and I have a VPC in Ohio. So, and also I have an account A4L shared, which is the shared VPC. So let's just do that now. So I want to pair my VPC with the shared VPC. So let me just call it shared, right? So my VPC with it. So on this side, I'm actually in the Apps for Life shared account. So I'm going to use shared VPC. And then I'm going to say, is it in a different account? I'm going to say, yes, it's in a different account because I'm going to connect from Apps for Life shared, which is, say, my partner company's account, to AWS Pretoria's account, which is one of these. So just let me log in quickly, I think. Okay, let me just go to the Northern Virginia region. Okay, so if I were to select this, I can see that this is my account number here. So I'm going to copy that, and I'm going to do a not cross region. So right now it's Northern Virginia, and the other one is also Northern Virginia. But you can see that the accounts are different. So it's another account. I will put the account ID here, and then the VPC region is the same except the ID. Now it's saying I want to pair with another account. So I want to pair with from 23984 to this account. So I'm pairing with that account, but that account is in the same region. I can even pair with another region. So I'm going to choose the same region because I'm pairing with Northern Virginia. And it says VPC ID of the acceptor. So I'm going to go back here, and I was going to pair with my VPC. So this is the VPC ID of my acceptor. So I'm going to click here. Just drag this a little bit on the top and then copy the VPC ID. Go back to the peering connection. So in this case, Apps for Life shared became the account that is requesting the VPC connection, and Apps for Life AWS Pretoria became the one that is accepting the connection. Okay, so I create a VPC peering connection. Okay, great. So now what you will see is it's saying pending acceptance. So I cannot accept this request because this request was made from shared to Pretoria. So let's go to Pretoria. Let's go to VPC Peering Connections. And I will see that there is a new peering connection request. When you do cross accounts, it does not propagate the tags. Okay, so now it's saying I need to accept the request. So this is now, imagine you are asking a third party to pair your VPC so that you can consume or provide resources to that. So I'm going to accept this. I can choose to reject it. But by virtue of doing this, that does not really solve the problem, because all you have done is you have established the connection between the VPCs. But what you have not done is told the subnets within the VPCs using their routing tables that if you want to go to the other side, to the other VPC, that you need to use this peering connection. In order to do that, you go to the route tables now. So I've paired it with shared VPC, right? So I go to the route table of shared VPC, okay, and I go to the other side of the peering connection, and my shared VPC here has a CIDR block of 10.0.0.0. So I'll copy that. Okay, and then I'll go to the other side in the route tables of my VPC, and I'm going to choose the route tables, and I'm going to edit the route, and I'm going to add another route, and I'm going to tell this VPC, which is the 10.10.0.0 CIDR, if you want to go to this other VPC, which is 10.0.0.0/16, then use the peering connection. And the peering connection is shared VPC. Now, as soon as you do this, any subnets that are associated with this VPC know that if you want to hop from my network or my VPC, virtual private cloud, to the other side, you need to use this peering connection. But this is one way now. You still need to establish the reverse order. If you don't do that, traffic will flow from here to there, but it won't know its way back. So in order to do that, you will need to copy this IP address of this my VPC, go to the other side, okay, go to the route tables of the shared VPC. Say, for example, I want to update the routes on both, so I'm going to do it on this side on both. So I'm going to paste it here. I'm going to select peering connection and shared VPC. And remember, there are two routes, so I'm going to also update the other route table. I'm going to paste that there. And so suppose if you only wanted a subset of the subnets that are associated with one route table to access the other VPC, then you wouldn't have to do this. You are doing this because you want all the subnets that are associated with both the route tables to be able to access that. Right. So by virtue of doing this, now you have established connectivity between this. I have set up Ec2 instances that I can demo how the connectivity will work. But trust me on this, as soon as you do these activities, that is, you create a peering connection between VPCs within the same account or between VPCs across accounts, accept the peering connection and update the route tables, you're sorted basically. Now, what I also want to do is show you now a VPC that does not have access to the internet itself, but needs to access some shared resources. So what I will do is I'm going to go into this advanced network demo, open that VPC. So this is a demo for the gateway endpoint. Okay, So now let's see first what VPCs we have. So if I go to VPCs, I have A4L secret VPC. Okay. Now let's see if this VPC is associated with an internet gateway. Okay. So let's go to internet gateway. And you can see that clearly there is one internet gateway. So obviously this does not have any network connectivity to the internet, which means this VPC is completely isolated. Okay. What I'm going to do now is I'm going to create a S3 bucket. Now the demo is a VPC gateway endpoint. So basically you're trying to access from a private VPC a AWS global resource such as a S3 bucket, but without any internet connectivity. Okay, so this S3 bucket, so there is this S3 bucket, and let's just have a look at this one as well. Okay, so there are two S3 buckets here, as you can see. Okay, now what I've also done is to prepare for this demo, I have created an EC2 instance. And if you want to access the instance, normally what do? You normally open an SSH connection to the instance, or you use Ec2 Instance Connect. Both of these options need an internet connection. But remember what I said at the start. This VPC does not have an internet gateway, which means I won't be able to access this instance using any of these mechanisms. So I cannot access. Let me show you that first. You can see that this instance does not have a public IP or a public DNS, which means I cannot sit on my laptop now, open a browser client and access this VPC. It's not going to be accessible. Okay, so the other option is EC2 Instance Connect, but EC2 Instance Connect also needs internet connection. So I've set up Sessions Manager, which allows you to connect to the instance without using SSH keys or Bastion hosts. So this is almost like a connection, a serial connection to the EC2 instance, and does not use any networking, basically. Okay, so now I've hopped onto that, and if I say AWS S3, there is a client installed already. So I won't be able to access the S3 buckets. So what I need to do is I need to create a VPC Gateway Endpoint. So I'm going to create a VPC Gateway. So you click on endpoints in order to create a gateway endpoint. Click on create endpoint. You search for gateway. There are two types of gateway endpoints, Dynamodb and S3. I'm not familiar with this. So these are the two types of gateway endpoints. So I will choose S3 and I will choose my VPC. So I want to privately connect through the S3 bucket from my VPC without using an internet connection. And I will choose these subnets. There are two routing tables and there are about 9 subnets associated. I just used a CloudFormation template from the internet. So create, and I'm giving full access for now. So right now, what I've achieved through this whole exercise is that I've created a shared, a gateway endpoint that basically allows my private VPC without any internet connection to access S3 services. Okay, so now if I go back to Instance Connect, okay, I think as soon as it connected, it actually showed the VPC. If I were to come back to the screen, just hold on one second. The timestamps are no, these are not the timestamps. It is actually displaying this, the S3 buckets that are there on the endpoint. But if you remember when I clicked earlier, it took a while to actually display this. So let me go and delete the gateway endpoints. But before I do that, I also want to show you something else. So as soon as I create the gateway endpoints, what it essentially does under the hood is it creates something called a prefix list. So it should be the VPC with the 9 subnets. What am I missing? Subnet associations, summary, roots. There should be an entry here saying prefix list. I'm not sure what's going on here. AWS. Oh, there it is. Okay, sorry, I just had to refresh the screen. Okay, so what you're doing, what it is doing here is so that AWS does not map it to explicit IP addresses. It creates like an alias, a prefix list alias, and it says if you want to access the gateway endpoint, okay, if you want to access an AWS service such as amazon.com/ec3, then use this prefix list, and this prefix list use this gateway endpoint basically to go to that S3 bucket. And then on the S3 bucket side also, you can have something called an endpoint policy to restrict only access from a specific VPC. You can harden it to this. So what I can also do is, say for example, if I were to delete that gateway endpoint now, so you could see here, now I can query the S3 buckets, right? I can see that there are 2 buckets. If I go back here and delete the gateway endpoints, that's the gateway endpoint. See, you can see that this is the gateway endpoint. Actions, delete endpoint. Okay, let's go back to the routing tables and see the routes. Yeah, okay, refresh. Okay, so it hasn't deleted the prefix list, but remember this endpoint does not exist. Okay, so what it does sometimes is it says black hole. I will show you that black hole this as well. Black hole means it will draw packets basically which is destined to this destination. Okay, now let's try that command again, and this time because from that private VPC I can't access these buckets. See, it's taking longer right now, and after some time it will time out and it will say could not access these buckets, because what I achieved here is from a private VPC I managed to access an S3 bucket. So this is an ultra secure environment, and in that environment have managed to access my buckets. The next concept we are going to cover is transit gateways. Now in order to prepare for this demo, I set up a transit gateway because it takes about 5 or 10 minutes to set it up in advance. So let's just go and quickly do it. Yeah.
On
I
that,
just need 5 more minutes.
Okay, I was going to ask while you're speaking about time. Okay.
Okay, just 5 more minutes. Sorry, let me also do VPC Flow Logs. I will take 2 minutes for that and 3 more minutes for this. So let's go here. So let me show you VPC Flow Logs first. Your VPCs. Okay. So VPC Flow Logs basically track VPC metadata, not the packets themselves, only the metadata. Metadata such as source IP address, destination IP address, and all. So what I've done is I just opened, I've captured some packets prior to this demo, and then I just opened this packet, and you can see that there is no packet information. There is no data about what, if you were to use, for example, Wireshark and you used HTTP, you would get the entire payload information. That information is not available here. It is used for using metadata tracking. And then the other cool feature, okay, so VPC Flow Logs can be set up at 3 places. So one, like I said, it can be set up at the VPC level. So you click on the VPC, select Flow Logs, and you can set it at the VPC level. So I can create a flow log here, okay. Then the second one is at the subnet level. So I select the subnet, okay. and then you can create a flow log here. So now, if I create it at the VPC level, it will track all interfaces on that VPC. If I create it on the subnet, then it will track all interfaces for all EC2 instances or endpoints, interface endpoints within that subnet. Or I can even do it at the interface level. So to do it on the interface level, I can go to EC2 on the interface. So instances, I can select the instance, go to networking, go to the interface itself, and select flow logs here. And that's what I've enabled actually. I've created an interface flow log. And if I look at the interface flow log, the destination is in S3 bucket. So let me quickly go to this. I will just take 2 more minutes, Rian. Just 2 more minutes. Just bear with me, please. So as soon as you start writing data, then it will create a folder structure like so. And then within the folder structure, it will have gzip files that basically have all the data. So it has been collecting for some time. And if I were to unpack these gzip files, this is what you get. Okay. So that's for the interface endpoint. Now the next thing is the last thing I wanted to cover is the transit gateways. Now remember what the challenge was with the VPC. The VPCs was the main challenge was if you had thousands of VPCs, imagine doing that exercise for peering connections for each individual one of them. You're going to go mad basically if you had to do all of those. So in order to overcome that, you have transit gateway. Transit gateway is a regional construct. You can do inter-transit gateway peering connection as well. So you can create a transit gateway like so. You can create transit gateway. I'm going to quickly do this, but we're not going to wait till it's done because it takes over. Demo TGW1, just because I can't remember. Then it has the ASN number, and you can choose ASN number starting from 64,512 all the way to 64,512. So I'll just choose a 64,512. This is a BGP concept. And then what it is saying here is, it is saying if you want to do route propagation. So basically, if 2 VPCs are connected to this transit gateway, then you can do route propagation between those VPCs. And those routes will be propagated just like without you having to do like how you did with peering connections and so. However, on the route on the routes on the specific VPC, how the route tables were updated, you still need to continue doing that updates. So you can propagate route tables. You can propagate default route to the default route table. You can do the propagation. Okay. Now, after you create a transit gateway like so, then basically you create attachments. There are 3 types of attachments. You have VPC attachments. Let me just go to the one that I've already created. Right? Let me just do it quickly. What's going on? So look, I've moved to the Ohio region within the AWS for Life Pretoria account. And here I had already created a transit gateway. Remember, the transit gateway is a regional construct. So remember that one that we created over there with the -1, you couldn't see it here. So it's a regional construct. So once the transit gateway is created, you create attachments. And I've created 2 attachments for VPCs that are within the same region. So the finance and this, like we create peering connections, we created 2 this. So what I did was, in this case, I used the default VPC and the finance VPC attachment. I created 2 VPCs here. So let's just go to those VPCs quickly. So I have the finance VPC and the default VPC. And I want to show you the route tables quickly. So the same principle like you have with VPC peering connection, you have to update the route table. So for example, I can edit the route table here, add a route, and I can say, if you want to go to the other VPC, let's just assume for argument's sake. So I'm in the finance and I want to go to the default. So the default VPC, just hold on one second. Default VPC is in this subnet range. So I need to use the transit gateway instead of a peering connection. So I go back to the route tables. I can go to the private VPC route table. I add another route, and then I use the attachment. So I'll use transit gateway attachment. And by virtue of doing this, this is the same exercise that we did with the peering connection. You guys can go ahead and explore this or yourselves. So similarly, you have other types of attachments like VPN attachments. Attachments, and let me just show you the list of attachments. You have VPC attachments, which is what we've done. We have VPN attachments. We have peering connection attachments, which allow you to peer between transit gateways that are in different regions. The same way like we peered between VPC peers within different accounts. And I'm not familiar, this is a new option, I'm not quite familiar with this. So, but if you were to choose this, you can choose a transit gateway acceptor in a different account, okay? So hopefully from this demos, you guys got an opportunity to learn something new, or I could contribute in some way. I'm done.
Okay, thanks, Roger. It seems like we always like rush the end, but it was still some good information. We have a question from Basil. I think it's the only. Oh, no. So the first one was from Tuni that just asked why AWS has gateway endpoints only for S3 and Dynamodb. Is the reason because of technical limitations? Roger, I can see your mic muted.
So these are public zone services, so that's why I think I'm not really sure about why. But for interface endpoints, the difference between a gateway and an interface endpoint is that when you create an interface endpoint, a gateway endpoint is highly available by default. It's almost like an internet gateway. So you don't have to create it in specific. You don't have to add it to specific subnets and all. It just updates the prefix list and so on. But the interface endpoints, when you create interface endpoints, it creates a network interface in the subnet that you add it to. And by virtue of, so that's the difference between an interface. And also an interface endpoint is not highly available by default. You have to add it to every subnet in every availability zone that you want, this. So basically, that's the difference between a gateway and an interface. I don't know why AWS decided only 2 should be gateway and the remaining should be interface endpoints. I'm not really sure about that. Okay, Rian, the next question.
And then the next one is that one from Basil. If you scroll all the way down, he asks, is there a mechanism to measure bandwidth, latency, and jitter?
Basil, I'm actually not sure about that. I do have knowledge of VPC, but not to that level where you actually do this sort of analysis. I can actually read about it and do some research and get back to you.
So I did post a link there that because I'm not sure either. I could only think of that you can use Athena to query your flow logs, and then from there maybe get like all the packet sizes and sum them up and then group by minute or something, and then you can get those metrics that you want.
Okay, analysis, data analysis, yes.
Etienne, do you maybe know if there's any tool like that out of the box? That's fine. Let me get you up is.
Sorry, Ria. Hello, everyone. So as far as I know, there isn't a tool out of the box. In some cases, you need to roll out a specific solution. But in some cases, especially where you've got network interfaces running, there's quite a lot of metrics emitted, but I'm not sure if it's going to give you the level of detail that you want if you need to determine what your jitter is like. And it also depends on where you're connecting to and what's coming in from where.
Okay. And then Basil also asked just, Roger, you will need to come back and decipher costing for these networking options. I get the migraine when trying to understand them. So I think that's like quite broad, but maybe Roger, if you can highlight like what parts of all of these cost the most, or like what you should look out for, that would be nice.
Yeah. So from the costings page, from what I gather, is when you specially create these transit gateway endpoints that are cross region. Apart from the cost of this, you also have inter-region data transfer costs. So those are additional costs over and above that you have for the apart from the cost of the attachment and so on. So I've not really delved deep into that. So again, sorry, there are like 3 or 4 questions I can't answer. I'm not really sure.
Anyway. And then can the transit gateway connect directly to the internet? In other words, no need for an internet gateway with a connected VPC subnet.
No, you need an internet gateway. So the transit gateway can connect to the internet using you would need an internet gateway in order to connect to the internet.
Okay.
So lots of topologies have private VPC subnets, and then what they do is all of those VPCs are peered using the VPC attachments to the transit gateway. So imagine the transit gateway is at the hub. It's like a hub and spoke, where all these VPCs are peered, and then you do centralized management at the transit gateway routing table level. So that way you control traffic to your on-prem network if you want to go over a VPN connection or to the internet or through the, you can actually do some configs like that. And what I would advise you to do there is, if you look at AWS documentation, there are some transit gateway use cases. Let me just see if I can locate that. Transit gateway use case, and these transit gateway use cases give you 4 or 5 examples where you can use transit gateway in that setting, basically, like a hub and spoke, or for peering between VPC connection, VPN, or scenarios, basically on how which scenarios are ideal for using a transit gateway. For example, if you have only a couple of VPCs, then you can do a full mesh VPC peering connection if you wanted like a full end-to-end connectivity. You don't really need a transit gateway. But if your network is very complex, then definitely you should look at using a transit gateway.
Okay. And then the last one, I've done some testing around bandwidth already using iPerf 3. Could share results. Okay, Basil's just saying that he has some info around that. I also know about there's a site that does some testing, especially with E2Cs, and that just measures performance of the networks. It basically just analyzes the throughput that AWS advertises on their pricing page, and then just sees if it is as advertised. And there's a very specific word, up to, which doesn't mean that you get 5 gigabytes per second. It's basically like a burst bucket almost, but that's measured over URL-based link.
For some of these services, you can measure all of these things using AWS cloud metrics, CloudWatch metrics. So I think so some of these services have these metric elements, I can call it that, that you can actually to track this. But obviously there are some services offered by the AWS marketplace also in order to do monitoring and analysis. Yeah. So.
And then there's the last one from Roman asking, confirm a direct connect circuit can be connected to a transit gateway. If so, do the direct connect circuit and transit gateway have to be in the same region? So does the direct connect and the transit gateway have to be in the same region?
Yeah, there are some limitations, Rian. there are some limitations. I'll need to go through the documentation, but there are definitely some limitations around how, because remember, direct connect is basically a connection from your on-prem to the closest edge location that has like a provider that connects you into the this. So you need all the cabling and so on. But I think you have this direct connect WIFs that you need to create, and then there are constraints and limitations. I remember going through a video on that a while back, and there are some limitations on what you can do with direct connect in transit.
Okay. Just Hendrik. So I want to put a firewall, like FortiGate VMs. How easy is it to use that instead of a router from AWS?
The router is meant for routing traffic between VPCs. Firewall, I'm not sure if you are looking at a stateful inspection firewall or like this. But also AWS, I've seen recently that they have started adding this firewall and network manager services. If you look at that palette on the left-hand side, they have added new services recently. So you might want to look at that firewall options because they might have some of the features that were provided by third party. But it's very recent, like literally this year, 2020 January, new services that they introduced.
Oh, thanks, Etienne. Hendrik, I know if you do it like the VM way as well, it's not too difficult. I know that Momentum runs it like that, but they did have a few like scaling problems because those didn't scale like they thought they would. So it's definitely possible. You basically just have to change your routing tables to say, like, point all the traffic to that instance, and then on that instance, you must then create routing tables to send it out to the internet or to do whatever with it. That's just my understanding.